Hello everyone, welcome to IAS Baba's 60 days plan rapid revision series for Prelims 2022. This is day 5 and today we have the science and tech and these are the topics we are going to discuss. So here we basically have the astrophysics and the particulate physics. So important topics in the current affairs we will discuss. So UPSC asks mainly conceptual questions on the specific mains syllabus that is given in the UPSC, and moreover apart from that other factual questions which are in the current news, so that also become important. So I have brought some of the probable ones, so we'll see. So first is the Higgs boson. So Higgs boson is the fundamental particle associated with the Higgs field. So now what is this boson, what is this Higgs? So all those things we discuss in detail. And Higgs field is a field that gives mass to other fundamental particles such as electrons and quarks. And then not all fundamental particles have mass. For example, photon doesn't have a mass. And then the Higgs boson was proposed in 1964 by Peter Higgs and the other theorists to explain why certain particles have mass. And then scientists confirmed its existence in 2012 at the Large Hadron Collider, that is at CERN in Switzerland. And scientists are now studying the characteristic properties of the Higgs boson. So now coming to detail, friends, we know that the electrons, protons, neutrons, so all these are atomic particles, and the subatomic particles are the neutrons and protons. So they are made up of quarks and leptons. Okay, so these quarks, leptons, photons, so are these, they are called fermions. Okay, so fermions, they have a factorial spin, that is they have half spin or 1/3 spin. So likewise, and apart from fermions we have bosons. Okay, so these bosons have integral spin, that is 1 complete spin or -1 complete spin or 0 spin. So likewise, and bosons are those particles which will add to the physical property. Okay, so bosons are the ones which carry the force and energy, and fermions are the one which carry particles. Say for example, electron is a fermion, it is a particle, but however Higgs boson is a boson and it carries force. And here Higgs boson carries what kind of force? It carries the weight. So weight is also a kind of force, that is gravitation. And here the scientists say that Higgs boson, so that is present in the Higgs field. Say for example, this is a Higgs field. So I have converted this 3-dimensional field into 2-dimensional field. So here within an atom, so this is the field, might be the Higgs field, and within those, whenever a subatomic particle is present, say quark or a lepton, so that will form some depression. Okay, so just like how the planets and satellites, they form the depression in the space-time field of the universe, so the same way they also form. So this is how scientists thought that this is Higgs field, whichever the mesh we find it, and within them we find various subatomic particles which are floating on them. Okay, so here overall we make sure that the Higgs boson is a boson, not a fermion. So boson means it has integral spin and it has a force, and the force is the mass. Okay, we study about the other fermions and bosons a bit later. So as of now, we remember these. Then come to next one, the High-Luminosity Large Hadron Collider. So this is nothing but the upgraded version of the Large Hadron Collider. So Large Hadron Collider, CERN, so announced earlier this year that it is getting a massive upgrade which will be completed by 2026, and it will allow scientists to conduct even bigger and better physics experiments, and it will turn the LHC into High Luminosity Large Hadron Collider. So what is all these things? Say for example, this is the Large Hadron Collider we have. So at this point, the electrons, protons, neutrons or the subatomic particles will be accelerated, and they come all around here, and here they collide, and they will recreate the Big Bang. So whenever two atomic particles collide, so that is akin to Big Bang. And now here what other subatomic particles are being emitted, so those will be checked here. So now this was the LHC. Now we are going for this High Luminosity LHC. So here the path where the subatomic particles go, so that is the larger one, as the circumference is much bigger, and hence the collision will be more forceful and more subatomic particles can be emitted. So this is the High Luminosity Large Hadron Collider. And a brief look into Indian association with the Sun, that is India in 2016 became an associate member of CERN, and India was introduced as observer at the CERN in 2004. So whenever India is associated, friends, question have come. In 2004 also one question was there in UPSC prelims on this LHC, and in 2016 also it was there. So make sure that you will revise again and again all these things. And now the upgradation is going on, so it is our duty to revise. Then matters, antimatters and dark matters. So all these also the questions have come earlier. So what is a matter? So matter is all those things we can see in this universe. Say for example earth, sun, so all these are matters. Then antimatters. So these particles share the same mass as their matter counterparts, but their electric charges are opposite. Say for example positron is an antiparticle for electron. So the mass is same, only the charge that turned from negative to the positive. Then matter and antimatter particles are always produced as a pair, and if they come in contact, they annihilate one another and leaving behind pure energy. So when matter and antimatter collide, so but obvious they will vanish, and that gets converted into huge energy. And during the Big Bang, if matter and antimatter are created and destroyed together, it seems the universe should contain nothing but leftover energy. So if 100 matter and 100 antimatter collided, and then if we had got Big Bang, so now there will be only energy, no matter or antimatter. But however, a tiny portion of matter, that is about 1 particle per billion, so that managed to survive, and that is what we see today in this universe. And here, why that asymmetry? So why this matter is more than antimatter? So that is asymmetry of this universe. So this is the very reason why the universe exists today. So as we said, if there was symmetry, if there was 100, then universe would not have been existed. So it was not 100, it was 199. So that is why one particle is existing. Or might be it is 100 billion and 90 billion. That is why 1 billion particles they exist today. So here we learned about the asymmetry along with the matter and antimatter. Okay. Then coming to dark matter. Dark matter is that invisible matter which forms 85% of this universe. Okay. So here also one asymmetry grows, and here it is like this dark matter is much more than the white matter. And dark matter possibly could be the brown dwarfs or the failed stars that never ignited because they lacked the mass needed to start burning. So some stars they were formed in the nebula, but they were not large enough and they were not heavy enough to ignite a nuclear fusion, and they failed to burn like stars, and they might be the dark matters. Okay. And then Fermi Gamma Ray Space Telescope, that is the Gamma Ray Space Telescope, is used to detect the dark matter, and this telescope looks at gamma rays, the highest energy form of light. So wherever gamma rays are being detected, so it is an indication that dark matter is present over there. Friends, this gamma decay, beta decay and alpha radiations, so all these are being emitted during the radioactivity. So whenever we study the radioactivity chapter, we come across this alpha rays, gamma rays and beta rays. And then when two dark matter particles crash into each other, they might release a gamma ray. Okay, so that is why we detect these dark matters with the help of these gamma rays. So now what is a dark matter? Dark matter is that matter which is invisible to us. Say for example, black hole is made up of dark matter, and black hole has dark energy. Now, is dark matter equivalent to antimatter? Again, that we don't know, because there are some antimatters which we can see with our eyes, but there are no dark matters which we can see with our eyes. Only the evidence of this dark matter are being available. That is the gravitational lensing or expansion of universe, or might be photograph of any black hole. So all these show that dark matter, dark energy exists. Okay. So now I hope you got the difference between matter, antimatter and dark matter. So matter is that is visible, dark matter that is not visible or a black hole, and antimatter is the positron and others. Okay. So remember likewise. Then come to next, standard particulate model. So what is this standard model of particulate physics? So standard model only says that here we have some 17 subatomic particles, that is apart from your proton, neutron and electron. So inside them what other particles are there? So these are the ones. Say for example, inside a proton and a neutron we have so many quarks, and quarks are of different types. So on the basis of their mass and on the basis of their spin, so we can quantify them as the up quark, down quark, charm quark, strange quark, then top quark and bottom quark. So these are present basically in the proton and the neutron. And then electron themselves, so they are subatomic particles as per the standard atomic model, because they already have a small size, and here the electron, muon, tau. So all these are different types of electrons. And now, say for example, beta decay happens. So when beta decay happens, okay, so during the time of beta decay, a neutron, so that will be converted into a beta particle with a negative charge and with a positron with a positive charge, and one neutrino or anti-neutrino will be released. Okay, so here these antineutrinos and neutrinos, they are different kinds of subatomic particles. So here we have three types of neutrinos, that is electron neutrino, muon neutrino and tau neutrino. So electron neutrino is associated with an electron, and muon neutrino is associated with a muon, and tau neutrino is associated with the tau. Say for example, here we have an atom, and here the electron is rotating. So whenever beta decay occurs within the nucleus of this atom, so electron neutrino is released. Say for example, here instead of electron, muon is there. So whenever the radioactivity occurs, whenever beta decay occurs, so muon neutrino will be released. So likewise, the corresponding neutrinos will be released whenever beta decay occurs in the nucleus. So these are the fermions. So quarks and leptons, they form fermions, and I said fermions are the particulate matters. So they represent particles. And then we have bosons. So these are bosons. So bosons means the forces actually. So here we have various kinds of forces. So gluon is there. So gluon is the representation of strong interaction force. So what is a strong interaction force? Strong interaction force is that, say for example, inside the nucleus, we have so many protons, but these protons are having similar charges. So when they have similar charges, they have to repel, but there is one binding force which is binding all of them, although they have similar charges. That is the strong nuclear force. So this gluon is the strong nuclear force, and then we have the Z and W bosons. So these are the weak nuclear forces. So where is the weak nuclear force? Weak nuclear force is one where, like, that force which makes a neutron to split into a beta decay, a positron and a neutrino. So where does this beta decay occurs? It occurs only where there are bosons, that is the Z and W bosons. Or in other words, where does the beta decay occur? It occurs only when there is a weak interaction force. And lastly, we have the photon. Photon is electromagnetic interaction. So we know that light is emitted in the form of photon. So photon. So light is also an electromagnetic radiation, and it is also a photon. So these are various kinds of bosons. So now the Higgs boson was an additional for all these. So gluon was strong interaction, strong nuclear force, and Z and W bosons, weak nuclear force, photon, the light, and boson, the weight. Okay. So here the boson got added. So if any new particles get added, then we will update. Then come to next, Neutrino Observatory in India. So in the last slides, friends, we got to know where are neutrinos produced. So they are produced by the beta decay. And where is beta decay? So whenever a neutron gets split into positive and negative charges, neutrino will be released. But these neutrinos, so they have a very less mass. So mass is almost negligible, and their charge is also very meager, and they are least reactive materials. So every day millions of neutrinos enter our body and go out of our body. So they cause no harm to the human body as well. So to study their properties, India also thought up with the Neutrino Observatory. So in the West Bodhi Hills in Tamil Nadu, we had planned one, but Tamil Nadu government has opposed it recently. That is why it happens to be in news. So now INO project key pointers. So building underground laboratory for the non-accelerator based high energy nuclear physics research. So non-accelerator based. So this means here we are not accelerating any particles, just like we do it in the Large Hadron Collider. And then the National Neutrino Collaboration Group includes more than 50 scientists. Okay, so under this group, we are setting up this observatory. Then who is giving the fund? That is Department of Atomic Energy and then Department of Science and Technology. And make sure that you cross check and see to which ministry these two will belong. And then prominent features, we have underground laboratory and then magnetized iron calorimeter, which will have the world's largest magnet. So what is a calorimeter? That which checks the calorie. Calorie means the energy. So that which checks the energy level of the neutrino, that is magnetized iron calorimeter. So don't by heart. So make sure that you will understand every word and learn. Then Interinstitutional Center for High Energy Physics. So this is a management body, and this will look after the day-to-day researches that go on in the Neutrino Observatory. So these are all about the Neutrino Observatory. So just revise them because they are in hot current affairs. Then Lucy mission of NASA. So NASA will launch Lucy, the first mission to explore Jupiter's Trojan asteroids. So what are the Trojan asteroids? Say Trojan is something which will follow a person stealthily. Okay. So here a Trojan asteroid are the ones which will either lead or trail a planet in its orbit. Say for example, this is the Jupiter's orbit, and here some asteroids will be in front of this Jupiter and some asteroids will be behind them. So either they will lead or they will trail. So that is why they are called Trojan asteroids. So stealthily they move along with the Jupiter. And then Lucy expedition was named after the recently found fragmentary skeleton of a human ancestor which lived more than 3 billion years ago. So more than 3 billion years ago, we had one fossil of a human being. So on that name, the mission was named. Then the Trojan asteroids, they travel in two swarms, that is in the front and back, and these asteroids were created from the remnants of a primordial material that gave rise to Jupiter and other outer planets. So one primordial material was there, might be a big planet or might be an old star as well. So that gave various fragments, and hence these asteroids were the part of that fragment. Then coming to next one, the Lucy mission. Take a pic of this Lucy mission and remember, and here we can see one of the Trojan asteroids. Then come to next, eco satellites of NASA. So now NASA is going for this eco-friendly satellites. So it is using a green fuel. So what is that? NASA will test a propulsion system in space for the first time with the green propellant infusion mission. So this mission is green propellant infusion mission. So in this mission we are infusing green propellant. Then GPIM promises fewer handling restrictions that will reduce the time it takes to prepare for launch. So people can handle that easily because it is not so dangerous. The propellant blends hydroxyl ammonium nitrate with an oxidizer. So this is the chemical that is present in GPIM or the green fuel. So just like we got the question on triclosan or might be the polycarbonate plastic, etc. So whenever new chemicals come from the chemistry part of view, the questions will become important. So remember this chemical name, hydroxyl ammonium nitrate. Then it uses a non-toxic rose-colored liquid and it's a cold fuel. And then spacecrafts love hydrazine. So hydrazine is one of the liquid fuels, propellants used by the spacecrafts, but it's toxic to humans. So handling them with bare hands is toxic. So handling the clear liquid, that is hydrazine, requires strict safety precautions and protective suits and thick rubber gloves, oxygen tanks and others. But the hydroxyl ammonium nitrate, that can be used easily and that can be handled easily. So remember this chemical and remember the purpose of it. Then come to next is ISRO's Chandrayaan. So we compare Chandrayaan 1, 2 and 3. Okay. So government of India is planning for Chandrayaan 3. So in that context it becomes important. So to perform high resolution remote sensing of the moon surface. So this is one of the objectives of Chandrayaan 1. So that means the remote sensing is being carried out. So remote sensing is carried out by a remote sensing satellite. So that means the Chandrayaan 1 was only orbiter. Okay. And then to provide a three-dimensional atlas. So it used to take some pictures and that would provide one atlas. And then to conduct chemical and mineralogical survey. So this is also done by remote sensing. Then to test the impact on the lunar surface for its future soft landing missions. So Chandrayaan 2 was a soft landing mission. So that's why it was a prelude. And then the mission successfully detected the presence of titanium and calcium along with the iron, aluminium and magnesium. So mark these are the success of the Chandrayaan 1. Okay. So apart from that, Chandrayaan 2. So here the mission targeted the south polar region. So south pole of the moon, which was completely unexplored. And the mission focused on the extensive mapping of the lunar surface. And Chandrayaan 2 was to explore the south polar region of the moon that was totally unexplored. So but obvious. And in that attempt, so our Vikram lander that crashed down, but the lunar orbiter is surviving even today. So Chandrayaan 2 was not a complete crash down. So orbiter is staying. Only the lander and this rover, so they too were damaged. Okay, so even today Chandrayaan 2 orbiter is giving us information, so we remember that. And then next attempt is Chandrayaan 3, and Chandrayaan 3 consists of the rover and the lander. So here we don't have orbiter. See, why Chandrayaan 2 crashed? It was too heavy because it carried orbiter, lander and rover. So in order to reduce that, so next time we are sending only rover and lander. So it will not include any orbiter like Chandrayaan 2. And it aims to examine the areas that have not been receiving sunlight in some billion years. So there are some parts of moon so which doesn't get sunlight at all. So those areas are the areas of research in Chandrayaan 3. Then scientists and astronomers are suspecting the presence of ice and abundant mineral stocks in that darker parts. So mark this, the ice and minerals. So they are being searched. Then the lander of ISRO's Chandrayaan 3 will be powered by the throttle-able engines. In addition, it will be endowed with a laser Doppler velocimeter. So why this velocimeter is important? Because this word was present in the 2020 prelims. So velocimeter. So that is why whenever a name is present, whenever a unique name is present, so UPSC is not that insane to put it from anywhere else. It has purposefully put it to make sure that whether you have updated the current affairs and to check your current affairs aptitude. Okay. So for the vertical farming, so in that perspective, this velocimeter was introduced. So make sure that what is velocimeter, all those things we have to study. But obviously, the questions will not be repeated. From now on, we will be careful. Then, the NASA's Viper mission. So, the Viper full form is the Volatiles Investigating Polar Exploration Rover. And it's a lunar rover. So, it is a moon mission. And it is currently planned to be delivered to the surface of moon in 2023. So, next year. And the rover will be tasked with the exploring lunar south polar region. Again, this also explores South Polar region only, just like Chandrayaan 2. Then, the mission builds on previous NASA's rover called the Resource Prospector, which was cancelled in 2018. So, this is a sequel of this Resource Prospector, and it is the first resource mapping mission on any other celestial body. So, mark this, it is the first. So, if it is from NASA, so but obvious it would be first in the world. So, all these we remember. Then, the 2-deoxy-D-glucose approved by DGCI. So, what is this 2-deoxy-D-glucose? So, it is an anti-COVID-19 therapeutic application of drug 2-deoxy-glucose has been developed. So, it is a COVID-19 drug. So, mark this drug. See, COVID vaccine is different from a drug. Okay. So, vaccine is that which is given before the infection occurs, and vaccine is something which prevents a disease. But a drug is that which is given after the infection. So, that which relieves the symptoms and that which cures a patient from the disease. So, that is a drug. So, this 2-deoxy-D-glucose is a drug, not a vaccine. And it was carried out, that the research and production of this drug was carried out by the Institute of Nuclear Medicine and Allied Sciences. So, that is INMAS, and then a lab of DRDO. So, mark this DRDO. So, it is present here. And then in collaboration with the Reddy's laboratory. So, private institutes are not so important for us. Then, patients treated with 2DG showed RT-PCR negative conversions. So, RT-PCR gave the negative test report for the use of this. So, that means once if you give this 2-deoxy-D-glucose, so the COVID virus will be dying inside. Then the drug is taken orally by dissolving it in water. So, it is not an injection, it is just a tablet or a tonic. And it accumulates in the virus infected cells and prevents virus growth by stopping its viral synthesis and energy production. So, reproduction and energy production of virus will be stopped by this drug. So, mark this. And then its selective accumulation in virally infected cells makes it a unique drug. So, that is, so selectively it sits only on viral infected cells, not on every cells. So, there are minimum chances of side reaction also. So, we remember this 2-deoxy-D-glucose, which is a drug, not a vaccine. Then come to next, Israel's Iron Dome rocket defense system. So, what is this Iron Dome? So, it is nothing but a missile interceptor. So, here we have some radars that is being, and here we have a missile launcher. So, whenever a missile is launched from enemy country, so this will be intercepted like this. Okay. So, all domes, whatever we call, so all will be the interceptors. Even if we call the cyber dome, So that means that we are intercepting any cyber attack. So any attempt to attack our cyber infrastructure, that will be cut down in the middle itself. So this is the meaning of the dome, and here we have a comparison with the S400. So S400 was in mains question in the last year. So that's why here this is also a dome project. So this is also a missile interceptor project. So we will have a comparison, and then the specifications of this Iron Dome. It is a short range ground to air. So it is ground to air defense system and includes radar and Tamir interceptor missiles. So remember this Tamir, Israel's interceptor missiles. Then it is used for countering rockets, artilleries, then mortars as well as aircrafts. So anything in the air can be shot down, nothing as such shot. Then it is capable of being used in all weather conditions. So in rainy day, night, summer day, any day you can use them. Then Rafael claims a success rate of over 90% with more than 2000 interceptions. So 90% success rate. Then it can protect deployed and maneuvering forces as well as forward operating bases, okay, and urban areas. So anything it will protect. So all success is nothing but protecting someone else. So these are some of the specifications we remember. So maximum questions can be asked like this. So this Israel's Iron Dome project, what is it? This is a missile interceptor system. Then come to next, AmbiTAG. So Indian Institute of Technology, Ropar, Punjab has developed the first of its kind Internet of Things device, that is AmbiTAG. So what is this AmbiTAG? It records real-time ambient temperature during the transportation of perishable products, vaccines, and even body organs and blood. So the temperature measurement instrument it is, and then the device has been developed under the Technology Innovation Hub, that is AWAD, that is Agriculture and Water Technology Development Hub, and its startup Scratch Nest. Okay, so here remember AWAD and where, in which department it lies. So do a cross check here for polity. Then it is shaped as a USB. So just like the USB card, it is placed, and it is India's first indigenous temperature data logger for cold chain management. So mark this, and then it continuously records the temperature of its immediate surrounding from minus 40 to 80 degrees Celsius. So a very huge temperature range it has. So that makes it unique, and it generates an alert when the temperature goes beyond a preset limit, and the recorded data can be retrieved by connecting the USB with any computer. So all these are not so great. So this one makes it great. Okay. So friends, whenever India's indigenous innovation comes up, so UPSC will concentrate on them, and most probably the applications of these and some of the features of these can be asked verbatim. So at that point of time, your critical thought process, and apart from that, your revision ability. So those both will matter. Then come to next, the large collection of fast radio busters. So there was a collection of these fast radio busters recently. So in that context, what are these fast radio busters? So these FRBs are brief, that is, which come in few milliseconds. They are the brief bursts of radio waves coming from far beyond our Milky Way galaxy. Their origin is unknown. So we don't know from where they come, but they come as the radio waves, and they come in very short duration. Then an international team of astronomers recently discovered more than 1650 fast radio busters detecting from a single source in deep space. So they have detected a very huge collection of these, and then it was the largest collection of the mysterious phenomenon ever discovered. And then the source dubbed FRB 121102. Okay, so this was the name for this radio busters. So that was discovered using China's 500-meter aperture spherical telescope. So 500-meter aperture means what is the aperture of an antenna? So this, the surface area is the aperture of an antenna. So this is the length. So here it is the 500 meter, and this antenna, the large aperture antenna, so that has found out or discovered these fast radio busters. Then Psyche mission or Psyche mission, whatever you want, you can pronounce. NASA intends to launch the mission Psyche or Psyche by 2022, and mission will focus entirely on studying about the core element of 16 Psyche asteroid. So this 16 Psyche is a name of an asteroid. Okay. And this Psyche spacecraft shall land on the asteroid by early 2026. So the name of mission and the name of asteroid both are same. And over 21 months in orbit, the spacecraft will map and study 16 Psyche's properties, and using a multispectral imager and gamma ray and neutron spectrometer. So spectroscopy, so that is mostly used in medicine and the planetology. So whenever we are studying a mineral or a weather condition, these spectrometers are the must. So we make sure that the multispectral imager, then gamma ray and neutron spectrometers, magnetometers, so they all are involved in this exploration sector. Then the main aim of this mission is to analyze if the asteroid is actually a part of the lost planet and holds similar properties and elements. So we know that there was one lost planet, so which led to the creation of all other planets of Jupiter, Saturn, etc. So we don't know whether this Psyche asteroid also belongs to the same. So most probably it belongs because it also has similar properties. Then come to next one, Envision mission. So Envision is European Space Agency led mission with contributions from NASA. So both have contributed, and it is likely to be planned sometime in 2030s. So much later. And once launched, the spacecraft will take about 15 months to reach the Venus. So this is a mission for Venus. So Envision, V for Venus, and will take 16 more months to achieve its orbital circulation. And then the spacecraft will carry a range of instruments to study the planet's atmosphere and surface and monitor the traces gas in the atmosphere and analyze its surface composition. Okay, so here it is like basically the atmosphere and its gases are being analyzed and explored. Then Envision will follow another ESA led mission, that is the Venus Express. Okay, so this will be followed, and then that focused on atmospheric research and pointed to volcanic hotspots. So volcanic hotspots was explored by this Venus Express, and Envision will be a follow-up for this mission. And then other than this, Japan's Akatsuki spacecraft has also been studying the planet's atmosphere since 2015. So here remember Venus Express of ESA and then Akatsuki of Japan, and also remember the Envision of ESA and NASA's contribution. And also remember it is going to explore the gas traces and also the atmosphere. So these are the today's ones. And coming to the last part, friends, ultimately the greatest success lies in winning after every fall. So success doesn't lie in winning without any fall. So failures are the ones which are embedded within the success. So make sure that you fall every day, get up every day. So fall severely and get up aggressively, and come back, pull up your socks and fight better. So make sure that one day you will reach the zenith of success where you will be the top of the world. So that gives a great sense of achievement in your life. So do it all the very best. Good luck, friends.